All right, guys. What we're looking at today is continuing on with solving quadratics. And so far, we've gone over solving by factoring, because that's what we were just doing in the last problem, or the homework problem we went over, and 3.13, solving by factoring. Because if I get two things multiplied together to equal 0, one of them has to be 0. That's our zero product property. What we're looking at today is the second and third ways we can go about solving quadratics. And the first one of the two, I think, is going to be one of y'all's favorites, is solving by graphing. We're going to graph it. And wherever it crosses the x-axis, we're looking for what value of x is going to make the function equal 0. Yes, sir. Okay, but we're going to talk to Denny with what we need to do. Now, it's the x-intercepts. It's what values of x is going to make this function equal 0. What value of x is going to make the y value be 0? Where is it going to cross the x-axis? Now, when we look at this first one here, the first thing we need to do is graph it. In Algebra 1, you graphed equations of lines. Because if we wanted to graph the equation of a line, we needed 2 points. With quadratics, if we're doing the most basic ones or talking about it, we needed 5 points, the vertex and 2 points to either side, so we get an idea of what the U-shape would look like. But as we went over in the last chapter, the axis of symmetry reflects across it and goes through the vertex. So really, if we have the vertex and 2 points to the left or 2 to the right, the other two are going to mirror it. But the other big thing with graphing is we need this thing equal to 0, yes? And as I said repeatedly, especially throughout the year so far, is we're not graphing. Don't graph. We're not going to graph these by hand. And the reason for that is the graphing calculator. If we hit on the graphing calculator, you turn it on, and we hit y equals. Y equals will let us graph these functions. But for us to be able to graph it, we need the equation equal to 0. Essentially, we're getting the y by itself. We're getting it into the correct form. And we can type the function in. So our first function is what? X squared minus x minus 6, yes? So where we can get x is the button right next to alpha. And I'm going to clear this key history out. So x is the first one we get here. So we typed in x squared minus x minus 6. We have that typed in, yes? And then what are we wanting to do? We want to, well, there's a button up here that says graph. And there's the graph of it. Really, with any function, if we want to find the graph, we can type it in and say graph, and this calculator will show it to us. And again, what are we looking for? We're looking for where it crosses the x-axis, yes? So it's going to cross here and here, yes? It might be somewhat easy or somewhat hard to kind of tell what those points are, what the x value is. Now, if we look above graph, what does it say in blue? Table, because y'all have made tables before with x and y values. So what we can do is hit second graph, and it pulls up a table. And again, what are we looking for? We're looking for the x values that make y be 0. We're looking for what value of x will make this function be 0. So at -2, the y value is, and at 3, the y value is 0. So what is our answers? -2 and? So for us here, the solution is that x is equal to -2 and x is equal to 3. That's it. And we'll do another one. We're doing several of these. Now, if we wanted to check to make sure that we got this right, we could plug it back in. So we could plug -2 in. We could say -2 squared minus -2 minus 6 to see what this equals. Because if x is indeed -2, this should get us a value of 0. -2 squared is 4. -2 is +2 minus 6. So 2 plus 4 is 6. And 6 minus 6 is indeed 0. We can do the same thing with 3. 3 squared minus 3 minus 6. Well, 3 squared is 9 minus 3 minus 6. Well, 9 minus 3 is 6, and 6 minus 6 is 0. So if we wanted to check it, we could plug them back in and see, does it indeed equal 0? Let's look at the next one. What did we need these functions equal to? 0, yes? Is this one equal to 0? So what do we need to do to make it be equal to 0? Well, we can subtract 4x from both sides because we need this equal to 0. And if I subtract 4x from both sides, the left side is going to be -2x squared. Minus 4x minus 2 is equal to 0. So now can we graph it? Yeah. So in the graphing calculator, we could say y equals, so we can clear this out, -2x squared minus 4x minus 2. Hey, graph. Yep, you need the 4x. Now, where does it make the y value be 0? So we see that it does intersect. So if we look at the table, it's at -1, yes? Now, for all of these quadratics, there's always two. There's always two solutions. The other one is -1. There are always two solutions for quadratics. They're not always unique solutions. Second graph. So instead of putting -4, you put -4. Yes.
I don't know what I did, but it's like 1,000.
So you can scroll up or down.
I'll scroll it up.
Yeah, because if it's negatives, you'll need to scroll down. If it's positives, you'll need to scroll up. Because we can keep scrolling up or down, and it'll give us values continuing on up and down.
So would the other one be -2?
So the other one is -1. Now, again, we're looking for what value of x is going to make y be 0. The only spot it hits it is at -1.
So just write it twice.
Yeah.
Oh.
Now, we can write it twice, but we're going to have an even number of solutions if it touches the x-axis but does not cross it. What we call those points is that they have an even multiplicity. They have an even number of zeros there. If it crosses it, it only has 1. It's an odd multiplicity. Yes, sir?
How would I write?
So, x is equal to -1. Because what value of x made the function equal 0?
Oh, okay.
So we will always have two solutions. They might not be unique. And when I say unique, like the first one, we had -2 and 3. Those are two unique values. Here we do have two, but they're both -1. We can list it once. Questions on this here? Let's look at the next one. X squared minus 8x plus 12. Is this already equal to 0? So we can go on and type it in. So in the graphing calculator, we can hit y equals. Clear this out, we can say x squared minus 8x plus 12. We can type it into the first line. Now, one of the things I will tell you all to pay attention to is if you see up at the top, it says plot 1, 2, and 3. If any of those are in bold, like it looks like they're highlighted, instead of here where the print is black and the surrounding is white, if the surrounding's black and the print is white, you'll need to go up and select it. I'll show you this here and hit enter. So if it's looking like this here, we need to hit enter to turn it off. Because we can plot points that way and do stuff with that. It will cause issues if we hit graph. But if we graph it, we get this here. Yeah, if that's on, it'll do invalid dimensions because it's trying to graph whatever's in that plot. But if there's nothing there or it's not matching up, it won't work. Does that make sense? So we're looking for where it crosses. So the second graph will give us the table, and our two values are what? 2 and 6. So here x is equal to 2. So we could also write it as 2 comma 6. That's another way to write it.
Oh. And then you graph. No, you forgot the eggs. I forgot the eggs.
Okay, yep. So guys, any questions on this here? Yes, sir. Yep. And we type it in.
How do you get away from this?
Y equals for graph. Second mode.
All right, I can see how you got 2, but how'd you get
Keep going.
Oh, okay.
Mm-hmm. Now, one thing we can do, especially looking at the 2 points.
Hey.
Yes.
I still keep saying this. I calculated. It's the.
So since that plot 1 is on, it's not letting you graph.
So it has to be off?
Mm-hmm.
Oh,
Yeah. Because if it's kind of white print, that means it's turned on. So the calculator is going to try to graph the points or whatever's in plot 1. If there's nothing there, it's going to have issues and it's going to say it's not going to work. Any other questions, guys? Any questions on this here? Let's look at this one here. 1/2 x squared equals 6x minus 20. So what do we need to do for this one here? Well, we need this equal to 0. So what can we do? So we can subtract the 1/2 x squared. Because this will become 0 is equal to negative 1/2 x squared plus 6x minus 20. Because whenever we graph these, we need these equal to 0. Alpha y equals enter. Either one. No. Enter. So alpha y equals enter. And we could say negative 1 over 2. Now, I know there's one calculator at least that I need to update the software. Because one of the program or calculators, alpha y equals, okay, x squared plus 6x minus 20. So where does it cross the x-axis? No, it doesn't cross the x-axis. It's not no solution, it is no real solution. So if it doesn't cross the x-axis, it is no real solution. Mhm. But again, this still has two answers. They're just not real answers. We will eventually get to the point where we can solve this one here.
I'm good.
But at this point, it is no real solution. Questions on this here? So if it doesn't cross the x-axis, guys, if it doesn't cross the x-axis, we can't solve it by graphing. By the time we take the test, we're going to still have an answer, but we can't get to it by graphing. So for this homework assignment, if it doesn't cross the x-axis, it's no real solution. So any questions on these so far before we look at this next one? So let's look at this one here. So we can say y equals. Now, since it is already equal to 0, we can go on and type it in. So 4x squared minus 12x plus 9. And we can hit graph. Now, this one does intersect the x-axis, yes? What value does it intersect it at? Well, it does, but the spot that it intersects, it's between 1 and 2. So graphing does work well if it does cross the x-axis at whole numbers. Now, if we went through and found this, the actual x value is 1.5. So this one here, we would be better off using factoring because 4x squared minus 6x or minus 12x plus 9 does factor. Yes. So 1.5. Second, trace. And if we hit enter on the first one, value, we can type values in for it to estimate or tell us what the y value would be. And when x is 1.5, the y value is 0. Well, I knew this one here. So that's one way we could check it. But really, since this doesn't give us a nice value, we could factor it. So we would look for greatest common factor between these three numbers. Well, there's not one. So we could do our two sets of parentheses with 3 spaces. Since the third term is positive, the signs are the same and they match the sign of the middle term, which is negative and negative. Now, if we look at the factors of 4x squared, well, x squared is going to be x and x. Now, the factors of 4 are 1 and 4 or 2 and 2. So it's going to be 2 and 2. Factors of 9 are 1 and 9 or 3 and 3. Now, we can check this. 2x times negative 3 is exactly negative 6x. Negative 3 times 2x is negative, which is the middle term we wanted. So what this tells us is that this factors to 2x minus 3 times 2x minus 3. Now we can set both of these equal to 0. And we could solve from here. So we could add 3 to both sides for this one, which tells us 2x is equal to 3. Then we would divide by 2, telling us x is equal to 3/2. We can do the same thing on the other side. Add 3. Then divide by 2, telling us x is. So again, we do have two solutions, but they are the same. So again, graphing does work well if our solutions are integers, they're whole numbers. We don't have a decimal. So We'll use it for some of the next ones. Any questions on any of this here? So that was graphing. Now the other method that we have is the square root method. I have to email TI, Texas Instrument, and request the update. They will send me a copy of the update that's only valid for a certain amount of time that I can download onto those, yeah. And there's a certain software that you need to update them. And they only release this updated software for teachers or people in the education to use it specifically for that program. Whole bunch of hoops.
When you said updated, I was like, whoa.
Now, square root method is the next one we're looking at. Now, the reason or way that we can use the square root method is if there is no x term. There is no x to the first power. If we don't have x to the first power, or we have x inside a set of parentheses squared, we can use the square root method on one of these two here. And the first step in the square root method is to get x squared, or the set of parentheses squared, by itself. And whenever we have a set of parentheses being squared, there's no other x term in the equation that's outside of those parentheses. So we want to get the x squared, or the parentheses, by itself. So what do we need to do for this problem here to get x squared by itself? What do we need to do first? We can add the 31 to both sides. And if we add 31 to both sides, well, this becomes 0, telling us 4x squared is equal to 80. Now, what do we do next? Divide both sides by 4. Is x squared by itself? X squared is equal to 1. Well, now we need to get the x squared by itself, because we know what x squared is. X squared is 20, but we want to know the value of x, yes? So what can we do to get rid of that power? Well, what's the method called? Square root method. So we're going to need to square root both sides. Because the square root of x squared, the square root and square would so once we get it by itself, we're going to take the square root of both sides. We're going to take the square root of both sides. So, square root of 5. And this is why I had y'all get the yellow calculators, the other calculators. The graphing calculators, we're almost done, won't give us this here. It's going to approximate it. Because the square root of 5 is an irrational number, a non-repeating, non-terminating decimal. But the yellow calculators will leave it in radical form. But we have to add plus or minus. Whenever we square root both sides, we have to add the plus or minus. Because if we just talked about 2 squared is what? 4, yes? 2 times 2 is 4. Negative 2 times negative 2 is still 4, yes? So when we talked about this here, x squared equals 20. Well, 2 square root of 5 squared is going to be 20. Negative 2 square root of 5 squared is still 20. So we have to have the positive and negative case. Third step is to solve for x. Is x by itself? Yeah, so we're done. Now, guys, if we had a set of parentheses, there's a chance we'll have to do one more step. Because if inside a set of parentheses, like the one I wrote above, x plus 3 or x minus 3, we do still have to solve for x because it would be x minus 3, and we have to solve from there. Are there any other questions on this here? Could we have gotten this answer by graphing? What's the, well, the square root of 5, is that a nice number? Well, no. If the yellow calculator left it as a radical, it means it's a non-repeating, non-terminating decimal. So 2 square root of 5 is not a nice number. The graphing calculator would have showed us that it does cross the x-axis, but just like 1.5, it's not going to be at a nice number. We would have to approximate it. So this here, the square root method works better. Questions on any of this here? 3x squared minus 9. So we could try graphing it, but yes, we could use the square root method. And the square root method, the reason we can use it is, one, there's not a middle term. There's not an x term. So we can use the square root method. Yes. I would want to get addition or subtraction first. So I would want to add 9 first. 3x squared is equal to, we could have divided by 3 first, but we would need to make sure that we divided the 3x squared by 3 and the minus 9 by 3. We'd have to divide everything by 3. Now we can, by 3, telling us that squared is equal to, so we got the first step done, yes? We got x squared by itself. Now what do we do? Square root the x squared, square root the 3. Well, the square root of x squared is equals plus or minus the square root of 3. And again, whenever we square root both sides, we have to add the plus or minus. It's just square root of 3. Plus or minus the square root of 3. Questions on this here? Any questions on any of this here so far? Let's look at the next one. We had 2/5 times x plus 3 squared is equal to 5. So this one here, we could still use the square root method because the only place where x is inside the parentheses, yes? Is if I can get those parentheses by themselves, well, the square root of it would get the square to go away, get that power to go away, and leave us with just x plus 3. So the first thing we need to do is to get those parentheses by themselves. So what's the only thing with it right now? What's in front of it? 2/5, yes? So how can I get rid of the 2/5? So we can multiply both sides by 5/2 or divide it by 2/5. Because 2/5 divided by 2/5 is 1. Anything divided by itself is 1. So these will cancel out, telling me that I have x plus 3 squared. Now we need to figure out what 5 divided by 2/5 is. 25 over 2. And for these here, especially with the square root method, we want to leave it as a fraction. Because is the set of parentheses squared by itself? I mean, we have the x plus 3 inside, yes? But are the parentheses as a whole by themselves? Yeah, is there anything being added to the parentheses here? No. Is there anything being multiplied in front? No, so are they by themselves? Yeah, the x plus 3 we're not really concerned about. I'm more concerned about the parentheses as a whole. And since they are by themselves, we can square root both sides. Because the square root of x plus 3 squared, these will cancel, leaving us with x plus 3 is equal to plus or minus. We're going to take the square root of 25 over 2. Now, in the yellow calculator, to solve this, we're going to break this up as the square root of 25 over the square root of 2. Yep. So fraction, yeah. Second square root 2. So for these here, it asks for us to break it up. 5. Square root 2 over 2. All right, guys, focus back up here. Because we split it up so that we could have it in radical form. So the calculator will split it up into radical form for us. Any other questions on how we got to this point here? Is x by itself? So we have to solve for x by minus 3 from both sides. Because here the 3 minus 3 is 0. We'll leave it out front. Because the 5 square root of 2 over 2 and the negative 3 aren't like terms. So we put it out front, and that's our answer. Any other questions on this here?